acest eveniment și să vă mulțumesc pentru că sunteți alături de noi. Conferința de anul acesta a fost organizată în parteneriat cu mai multe universități de prestigiu din Europa și este adresată în special tinerilor, cercetători, studenți, masteranți, doctoranți.
This year's conference was organized in partnership with several prestigious universities in Europe and is especially addressed to young researchers, students, masters and PhD students.
Alături de noi se află colegii noștri de la Universitatea din Belgrad, Serbia, și episcop Constantin Prelavski, University of Schumann, Bulgaria. Aș dori să le mulțumesc pe această cale pentru implicare și dăruire. Tematica principală a conferinței este importanța protejării capitalului natural și cultural în concordanță cu schimbările climatice și metode moderne de reabilitare ecologică a peisajelor agricole și silvice.
With us are young people and teachers from University of Belgrade, Faculty of Agriculture, Serbia, and Episcop Constantin Prelavski, University of Schumann, Bulgaria. I would like to thank them in this way for their involvement and dedication. Particular focus of the conference, the importance of protecting the natural and cultural capital in accordance with climate change and modern methods of restoring the agricultural and forest landscape.
În fiecare an, această conferință este organizată în preajma Zilei Mondiale pentru combaterea deșertificării și secetei. Marcarea acestei zile reprezintă o ocazie importantă de a implica tânăra generație în diferite activități educativ-științifice. Astfel, am considerat un prilej foarte bun de a reuni la acest eveniment tineri din cadrul facultății noastre, de la toate specializările și tineri din afara țării, de la universitățile partenere.
Every year, this conference is organized around the World Day to combat desertification and drought. Marking this day represents an important opportunity to involve the young generation in various educational, scientific activities. Thus, we considered it a very good opportunity to gather at this event young people from our faculty, from our specializations, and young people from outside the country, from partners universities.
Lucrările care vor fi prezentate în cadrul acestei conferințe vor fi premiate și vor fi publicate în revista Mediu Cercetare, Reabilitare, Administrare, care se află la al 3-lea număr și care, începând din acest an, va primi SSN și va fi indexată într-o bază de date internațională. Așadar, vă mulțumesc încă o dată pentru prezență și pentru implicarea fiecăruia dintre dumneavoastră și doresc mult succes participanților.
The works that will be presented during this conference will be awarded and will be published in the magazine The Environment Research Charge Administration, which is in its third number and which, starting this year, will receive an ISSN and will be indexed in international databases. So I thank you once again for your presence and for the involvement of each of you, and I wish the participants much success. Next.
În continuare, o invit pe doamna prorector, Rozița Davidova, de la Universitatea Schumann, din Bulgaria, să ne adreseze câteva cuvinte.
Next, I invite Miss Vice Rector Rosita Davidova from Schumann University in Bulgaria to address us a few words.
Dear Vice Dean, dear students, dear colleagues, for the academic community of Constantin Prelavski University of Schumann, it's an honor to be co-organizer of the International Scientific Student Conference, the Environment, Research, Charge and Administration. We are confident that the forum will give all participants an opportunity to express themselves and a chance for their ideas, visions and abilities to be appreciated and given a place in the scientific community. The program shows that the main purpose of the event has already been fulfilled to challenge, attract and encourage young colleagues, undergraduate and PhD students to participate with their work on important topic for society. This forum provides an opportunity for young colleagues to take their first steps in science, to present their result, and for others to promote, meet, and exchange ideas and experience. Dear colleagues, this is the right place to discuss, to hear the competent assessment of your professors, and to identify ideas for future work. I wish you all success.
Așa cum v-am spus, alături de noi se află profesori și tineri, studenți masteranți și doctoranți de la Universitatea din Belgrad, Serbia. Ei sunt partenerii noștri foarte vechi și deja a devenit o tradiție de a avea alături la evenimente importante. Astfel îi dăm cuvântul domnului profesor Alexander Simici.
As I told you, with us there are teachers and young people, students, master students from the University of Belgrade, Serbia. They are our very old partners, and it has already become a tradition to have them by our side at important events in our faculty. Thus, I give the floor to Mr. Professor Alexander Simici.
Dear colleagues, dear students, dear Vice Dean, on behalf of the Faculty of Agriculture, University of Belgrade, we are honored to receive an invitation to participate in the student conference as co-organizers and participants. The conference, we know, will be held at the Faculty of Agronomie in the historic city of Craiova, Romania, on 16th to 17th June 2023. The theme for the conference, Environment, Research, Charge and Administration, builds upon the success of previous meetings. We are excited to learn about the latest research findings in agriculture, silviculture, cadastre and food science. Academic scientists and their students will be presenting on these topics and more. As Alexandra Trenfor once said, the best teachers are those who show you where to look but don't tell you what to see. The scenic and culturally rich city of Craiova will provide a delightful backdrop for the conference, creating lasting memories beyond the realm of science. We are confident that this conference will be both stimulating and productive. We sincerely hope that you will thoroughly enjoy the event and gain valuable insights from it. Allow us to conclude with two Chinese proverbs about teachers and students. Teachers open the door, but you must enter by yourself. And if you are planning for a year, sow rice. If you are planning for a decade, plant trees. If you are planning for a lifetime, educate people. We extend our best wishes for a successful and fruitful conference and express our gratitude to all organizers involved. Thank you for your attention.
Așa cum v-am obișnuit în fiecare an, în cadrul conferințelor noastre există și un moment artistic. Anul acesta avem alături de noi tineri minunați de la Liceul de Arte Marin Sorescu.
research and to make some new connection between students, between colleagues. And it's time to work. The first presenter for today, it is Belciu Marian Cristina, with topic the biodiversity of the Oltenia Sahara, southern parts of Oltenia from Romania, then coordinating teaching is this Professor Marian Niculescu. And I ask everybody to be in 15 minutes very effective because we have very long list with presentation today. And after each presentation, we have 1 or 2 minutes for any question.
Good afternoon. My name is Belciu Maria Cristina, and for today, me and my coordinating teacher, Mirela Niculescu, prepared the PowerPoint presentation about the biodiversity of the Oltenian Sahara, southern part of Oltenia from Romania. The thematic area is located within the developing locality in the south of Oltenia, in the southeastern part of Dolj County, near the port of Bechet. In the Danube middle, in an area with sandy soil, also called the Sahara Oltenia. The relief of the thematic area consists of plains and meadows covered by sand dunes. The total area of sands in southern Oltenia exceeds 140,000 hectares, being represented by strips of different widths along the Danube and on the left bank of the Jiu. On the sandy lands of Oltenia, specific biotic conditions allow the installation of a special plant communities. Natural habitats also have a specific structure and are home to a special fauna. The growth and development of spontaneous and cultivated plants on sandy lands, unlike other lands, presents something specific to them. Flora and vegetation characteristics of the area stems from the Bulen. In the sands area from the Bulen, more than 400 vascular species vegetate, some of which are found sporadically or rarely, being included on the red list. Among these, we can mention Achillea proleuca, Basia laniflora, Jasione montana, Viola hymetia, Viola chitaiberiana, Polygonum arenarium, Silene boristelica, Tragopogon flocosus, and Moluga cervina. From a floristic point of view, the sands in Oltenia, in the Damulen area, are different from the sea wasp. Boya and Paun, 1964, divided the vascular species that grow on the sands of Oltenia into 2 broad categories: species characteristic of sands and species that are not characteristic of sands, but which grow and develop relatively well on sands as well. In this image, we have Basia laniflora, Viola chitaiberiana, Viola hymetia, and Polygonum arenarium. In this image, we have Tragopogon flocosus, Silene conica, Potentilla arenaria, Centaurea arenaria, Moluga cervina, and Corticum arenarium. In these images, we have Salsocali, Salicornia species, Chenopodium glaucum, and Sueda maritima. These species are to be found in the Nature 2000 list and on the red list in all the countries. The nature capital in this area, which has already suffered big transformations due to the eco-pedoclimate changes, will lead to a better management and preservation of the area. The herbaceous plant associations in the thematic area are classified in the following categories: grassland associations, communal ice trees, acacia plantations gaps, aquatic associations in the Danube middle, ponds and around ponds. In this image we have Prestucetum vaginate oltenicum. In these images we have Plantagetum indice and Brometum tectorum. In this image is Tribulotragetum and Botriocloetum ischemi. Regarding woody vegetation, the most important woody plant communities are Quercetum roboris oltenicum, Frasinodanubialis ulmetum, Stellarium nemori, Alnetum glutinose, Bromosterilis robinietum, found around the sandy soil area. Very important from the fixed descents. Salicipopuletum, regarding the fauna of the thematic area, we must give a special importance to the ornithofauna. According to the Nature 2000 standard form, a number of system protected bird species with community or priority species status should be found in this area. They are classified into two broad categories. Bird species listed in Annex 1 to Council Directive 2009-147 EC. Egreta garzetta in first image, Nycticoras in second image, Platalea leurocordia, Anthus campestris, Coraceus garrulus, Caprimulgus europeus, Lanius minor, Emberzia fortunana, Lanius colurio, Silvia Nistoria, Aita niroca. In this third image we have Falco vespertinus. From the duck species Aitea niroca, Alveola ranoides. In the third image we have Coraceus garrulus, which make the nest in the sandy banks. Species of birds with regular migration not mentioned in Annex 1 to Council Directive 2009-147 EC, Corvus frugilegus in the first image and Hippolytes pallida in second image. Nature 2000 in Romania. The following Nature 2000 habitats are found in the research territory. Habitat 3115, natural eutrophic lakes with magnopotamion or hydrocharidon type vegetation. In this image we have habitat with Nufaluteum. In this image, dune with Hippophyra rhamnoides. 2113 fixed coastal dunes with herbaceous vegetation, grey dunes. 6,214 habitat subpannonic steppe grasslands. 91 E0 alluvial forest with Alnus glutinus and Frasinus excelsior. Alnopadion, Alnion incane and Salicion albe. 91 F0 riparian mixed forest of Quercus robur, Ulmus levis and Ulmus minor, Frasinus excelsior or Frasinus angustifolia along the great rivers, Ulmenian minors. In this image we have Salix alba and Populus alba galleries. The agriculture in this area is still developed and it has adapted to the climate and the certification conditions. Without agriculture we can't have our daily food. In this area is cultivated very well Arachis hypogea. Also, at the University of Craiova, there were created by a research group two breeds of Arachis hypogea. The two breeds, Solar and Venus, are cultivated in Tâmburești Experimental Research Station. The people of the sandy soils area grow with great success the watermelon and melon. In the recent years, has been cultivated for the first time the species Ipomoea patatas, sweet potato, in the sense from this area. This species is grown very well in this area with a minimum of irrigation. This experiment has been made at the Double N Research Station. Breeds from South Korea have been brought. Other species which are developed well are Lavandula angustifolia. The people of the sandy soil area deal with growing sheep and goats, even if sometimes the climate conditions are difficult. With milk from sheep and goats raised on this lands area, the people of the sandy soil are made homemade cheese. Also, for the plant and the animal species, the climate changes and the certification of the area have a negative impact because their habitats are affected. Big parts of forests have been cut down, the most important, the acacia-free forests. The sandy areas have spread the phenomenon of desert-like, took up the southern part of Oltenia area in contrast with last century. A number of invasive species grew more in crops than in other parts. The example Phytolacca americana, Erigeron anus, and Ambrosia artemisifolia. They produce a lot of damage and are difficult to be destroyed as not much information exists about them. In order to fix the sandy soil, the Robinia pseudoacacia is recommended. After the communist period, the acacia forests have been cut down irrationally. This has led to the sand expansion and desertification increase. Every year, we have participated with the students of our faculty to the reforestation of this area. We have used two species, Robinia pseudoacacia and Greditia triacanthus. These species are very important for fixing of sand desertification reduction. In this image, we have images from the action Grow Together from Dobrești. We have images of the action Romania Takes Roots from the Buleni. In conclusion, the ecopedoclimatic conditions influence biodiversity around the world. The loss of biodiversity affects all of us. We must preserve biodiversity. It is necessary to ensure the durable use of the plant and animal resources. We should avoid the loss of biodiversity at the world level. Thank you.
Okay, thank you for your presentation. Any question?
Just one question about irrigation in that area. Can you tell us about water? Is it underground water or river water? Is it difficult to irrigate in that Sahara, like Sahara Desert?
In this area, underground, we have the Jiu, and this from
Very deep water, or from the river Jiu?
from river Jiu. Underground is a high, is high.
Very deep.
Very deep.
What's your name?
I will speak loudly, maybe.
Okay, maybe it's better, yeah.
Yeah, well, if nothing is done about it, how far would you expect this area to extend, or is going to be like this without doing anything? Is the lack of trees going to make the area grow larger?
This area is in a continuous expansion. If we don't plantation acacia tree forest.
Okay, we can moving on. The next is Popescu Stefania Teona, coordinating teacher is Mariana Niculescu, and your topic is diversity of the macromycetes and bryophytes in the Valley Otașu, Vâlcea County.
Hello, my name is Popescu Stefania Teona. I'm student at the University of Craiova, Faculty of Agronomie, Forestry Specialization, in the second year. And now I present the diversity of macromycetes and bryophytes in the basin of the Vâlcea. My scientific coordination is Mariana Niculescu. The territory under study is located along the Otăsău stream and covers an area of about 300 kilometers. This area is part of the Buila Vânturaritsa Massif, which is a Natura 2000 site, RO HCI 0015, Buila Vânturaritsa, RO SPA 0025, Cozia, Buila Vânturaritsa. From a biogeographical point of view, the research area falls into the biogeographical regions, alpine and continental. This is a map. Geomorphology and geology of the region. The Otăsău Basin, as mentioned in the previous subchapter, includes two relief steppes, the mountain steppes and the subcarpathian area of Oltenia. According to the physical geographical division, the mountain steppe belongs to the Central European province, the Carpathian subprovince, the land of the Southern Carpathians, the Western district, Godeanu-Parâng. The most important peak and summit of this mountain, which belong to the Otăsău Basin, are the following: Cădrica Peak, Piatra Mountain, and Cacova Summit. From a geological point of view, crystalline metamorphic formation can be distinctive in the mountain area. Crystalline belongs to the unit of the Getic Flow, the Lotru series. Hydrogeographic characterization. The hydrographic network of the research territory is represented by the Otăsăului Valley, together with its numerous tributaries. Otăsău, a left tributary of the Bistrița, which originated in the Curmătura Builei and collects the water from the superb slopes of the Piatra and Albu mountains, Bulzului Valley and Pătrunsa Valley. This is an image with the forest, the nature, general characterization of flora and vegetation from the research territory. All the studies carried out in the area of the Otăsău Basin, an integral part of the Buila-Vânturața National Park, and reflected the wealth of flora and fauna species, supporting the need to protect this complex of form, association and landscapes. The landscapes offered by this corner of the country, bare rocks and impressive steppes, next to smooth plateaus, winding pens and shady forests, glades full of light delight the eye of nature lovers. The number of species reported from this corner of the country represented about 13% of the total taxa known from Romania's flora. The best represented are the families Asteraceae, Poaceae, Rosaceae, Brassicaceae, Ranunculaceae. In the Otăsău Basin, there are numerous species of endemic, rare or endangered plants. This category of plants from the research territory represents a fairly large number of the Romanian gene pool. Regarding the vegetation in this territory, we can mention the pure beech forest, grouped in the association Simpticocordati fagetum vida, have a wide distribution in the research territory. Mixed forests of beech and fir are spread in the mountains floor of the research territory between 700 and 1,200 meters altitude. The temporarily flooded part of the valleys, mountain streams or lands with excess humidity, which provide good condition for the development of hygrophilous or hygrophilic species, is occupied by anemones. At lower altitudes, you can find any niche belonging to the association Stellario Nemori alnetum glutinose long. 1957, and at higher altitudes, anemones included in the association Telechio speciose alnetum incane colde. The spruce forest included in the association Hieracio rotundati picetum, they stretch in the form of a belt between 1,300 and 1870 meters altitude, also occupying significant areas. The thickets built by Prunus spinosa and Crategus monogena are frequently found in the hilly floor and less so in the lower mountain subfloor. Phytocoenoses built by Coryllius Avellana prefer moist and cool valleys, settling especially at the edge of forest. The diversity of Macromycetes and Bryophytes found in the Otăsău Basin. Considering regarding the method of work and presentation of Macromycetes and Bryophytes from the studies territory, the overview of Macromycetes in the research territory was developed based on own research carried out between 2021-2022. For each Macromycetes species, the ecological group, the biological form, the substrate, the collection period, the locality, and whether the respective species is edible, inedible, or poisonous are indicated. For the identification by Bryophytes species, the following work was mainly used: Bryophytes from Romania and user Muns and Frank Planzer. The mycological flora of this territory is particularly rich and diverse in composition. Most cryptogames find in this area the most favorable condition of their development. Following the analysis carried out on the Macromycetes encountered in the Otăsău Basin, 82 species of Macromycetes were identified, belonging to a number of 56 genera and 24 families. Auricularia mesenterica and Dedale bercina. Dacrimices palmatus and Calocera viscosa, Trametes versicolor and Fistulina hepatica, Letiporus sulfureus and Ploriporus xvamosus, Cantarellus cibarius and Lactarius piperatus. Taking into account the biological form, the obtained results show that the highest percent is held by Mycetogeophis, following by Exilic Myceotoepites, Arboreal Myceotoepites, and Pteric Myceotoepites. This is a chart. For the point of view of the ecological group, the predominance of lingicolors, saprophytes, following by mycorrhizal species, humic saprophytes, lignicolus saproparistes, and follicular saprophytes. Most species are inedible, following by edible ones. Poisonous species have the lowest percent. Poisonous, inedible, and edible. Bryophytes found in the Otăsău Basin. Bryophytes are small eutrophic plants commonly known as mosses. Most mosses prefer moist biotopes, forests, meadows, swampy areas, etc. According to the substrate on which mosses live, they can be terrically on the ground, sexical on rock, and cortically on the bark of trees. The vegetative body is stellioid or format. Nechera crispa and Funaria hypogrometrica, Dicranum scoparium and Climacium dendroides. The importance of bryophytes by absorbing large amounts of water. Mosses or bryophytes play an important role in reducing the action of torrents and on slopes from the mountain floor to the alpine one. Growing on rocks together with lichens, they thicken the ground depth of their game topic and sporotype, the humus blanket, making it possible for other plant species to grow on these rocks. Most can be used as bedding for cattle, to fill matres in mountain areas as a thermal insulating layer between greenhouse window, or to grow plants whose moisture must be preserved during transport. The genus Sphagnum plays an important role in the formation of peat, and dry and sterilized is successfully replaced the peat. Some species developing in large quantities in mountain and lowland hay prevent the development of other plants. In this case, the muscle must be removed by racing. Conclusions. The general aspect of the vegetation in Otăsău Basin is a reflection of very varied station condition, to which is added the influence of anthropozoogenic factors. Woody vegetation is represented by forests, thickets, and thickets. In the upper basin of Otăsău, forests occupy the large area. Following the analysis carried out on the Macromycetes encountered in the Otăsău Basin, 82 species of Macromycetes were identified, belonging to a number of 56 genera and 24 families. From the Otăsăului Basin, 24 species or bryophytes were also identified in Vâlcea. The overview of bryophytes from the research territory was made based on our research, but also on geographical data. The 24 species of bryophytes identified in the Otăsău Basin belong to 24 families and 2 classes, Hepatice and Murci. From the total of bryophyte species identified in the Otăsău Basin, 5 species are found in the list of rare, endangered, or vulnerable species. Special attention must be paid to the protection and conservation of biodiversity, because the research territory is located in an area where forests are overexploited. Thank you.
We are going forward, and I invite the author of the next paper. The authors are Alexa Stepanovic, Neboja Markovic, and Zoran Prazic, and the scientific coordinator is Zoran Prazic. The name of the paper is Mechanical Composition of Grapes and Berries of Grape Wine Varieties Grown in Highlander.
I'm coming from University of Agriculture in Belgrade. My coordinating teachers are Neboja Markovic and Professor Zoran Prazic. My team of my research was mechanical analysis of grapes and berries of varieties grown in monastery Highlander. Also, I will talk about its location on Mount Athos, about that monastery. I will talk about vineyard that is called Sabino Polje in Serbian, or in English, St. Sava's Field. Also, I will represent some climate conditions of this area. Also, we will represent clone selection in that vineyard, then methods and conclusions. Mount Athos is the third branch on the Halkidiki. It is a peninsula in the Aegean Sea in Greece. On Greek language, it is called Agionoros, and it is a unique monastic republic in the world. It is autonomous territory in Greece, and also today there we can find about 20 Orthodox monasteries, countless keys and cells that were created in this small area. Today the Agionoros, or Mount Athos, represents the spiritual center of all Orthodox nations. Climate on this peninsula is mostly warm and dry, and wines are grown in that conditions. Also, the region is sunny, and there is a little bit of deficit of some waterfalls per year, because the optimum is 460, and as you can see, there is, how can I turn later? Oh, later. Okay, never mind. As you can see, we have only 260 millimeters. Vegetation period is about 247 days, and the optimum, the average temperature in this growing season is 21.2 Celsius. Those are the average maximum and minimal temperatures. As you can see, in July and August are the highest temperatures, and in January are the minimum. Also, humidity. The annual humidity is 67%. Because of that, this area is good for growing the wines and also for making wine. This is a graphic that represents hours, monthly solar radiation for on this area. The month that has the highest and that has the highest percentage of the hours is July. When we talk about monastery Highlander, it was founded in 1189 by Saint Sava and his father Saint Simeon. They were rulers from the Serbian Nemanjić dynasty. It lasts about 8 centuries, and also it is fortified and donated by Serbian people and rulers. Highlander Monastery owns the entire third of Mount Athos, that is about 8,500 hectares. It has its own economy, its vineyards, forests, olive groves, and others. In conclusion about Highlander, we can say that is the only Serbian institution that lasts without interruption for almost about exactly 825 years. Vineyard Saint Sava was planted in 2008 on 15 hectares. It is the trellis type and with single geo training system. Spacing between rows is 2.5 meters, and in row between plants is 1 meter. There are some different clones of the most famous world wines. For example, Merlot, Cabernet Franc, Cabernet Sauvignon, Alicante Bouschet, and also we can find there Marcellan, Prokupac, and Smederevka that are Serbian species. All were grafted on or Richer 110 rootstock. At the end, we can say about this vineyard that the position, exposure, and slope of the plots, composition of the soil, and all other features are giving us the high quality wines. This is the picture of our vineyard. It is that's not the whole picture. We can see that it continues. Yes. Those are the wine cellars. On the left side, we can see a new wine cellar, and on the right side, there is an old wine cellar that is located in monastery itself. New wine cellar is a updated building from the 18th century that have thick walls that provide necessary humidity and temperature for storing and carrying of our wine. Those are the pictures and some specifics of Merlot, also Cabernet Franc, Cabernet Sauvignon, Alicante Bouschet, it is on Serbian, no? Methods that we took in this vineyard were mechanical composition of cluster and berries from Markovic and Prvic, my professors. The research was carried in 2018 at the time of the grape harvest, when we took 10 bunches of each cluster, and then we took our analysis and we measured their dimensions, also the mass, and all others. The ultimate goal of this research was to determine characteristics of clones that were grown in this area, in this specific climate. Those are the pictures. This is our laboratory in our monastery. This picture in the middle is a plan of our vineyard. Also, those are some of the results. Here we can see that metal clones 1801 and 347 are shown the higher mass of cluster, and the percent of 861 of skin tells us that those clones have enough percent of phenolic compounds that are responsible for color of the wine. Also, the Cabernet Franc clone to 114. This variety can be mixed with Cabernet Sauvignon. Also, it is rich with tannins in its skin. Also, the percentage of massacre shows us that this clone was higher than the standard of itself. Cabernet Sauvignon, it is cosmopolitan character variety. It is used for making the top quality wines. And in the Helander Monastery, in their vineyard, the percentage of the mass in the berry compared is higher, significantly higher than the standard variety. This clone shown the higher percent of tannins and acids. Also, the large amount of tannins in the aging process gives red wines the necessary body and structure. Alicant Boucher, or on the French Tentoir, it is used for giving the wines better color, and the mass of 537.6 grams shows that this clone it is duplicate its mass of the standards. The higher mesocarp shows that yields of the berry is high, and because of that we have a higher percentage of juice. And for example, this variety of vins is special because colored substances are located in its mesocarp, also in skin. In conclusion, we can say that based on the analysis of locality conditions and agrobiological and technological characteristics of those clones that we mentioned, we can say that this location of St. Sava field is sustainable for growing all these listed varieties. And we can say that, for example, Merlot wines are characterized by a high percentage of anthocyanins. For example, Malvidin group of those anthocyanins are in the most percent, and they're good for heart, for lungs, and all the global health of people. Also, in the conclusion, we can say that this specifically gives St. Sava fields wines of exceptional quality. And thank you for your attention.
Any questions? No, okay. The next is Tanner Karim. Here. Okay. It's coming from University of the Schumann, Konstantin Preslevsky. We will present about the ways and use of intelligent systems in agriculture.
Ways to use intelligent system in agriculture. В съвременното селскостопанство интелигентните приложения като изкуствен интелект и компютърно зрение се използват в помощ на фермерите. Изкуственият интелект участва в дейности като прогнози за температура, валеж, влажност и състояние на почвата. Дроновете, използващи изкуствен интелект, работят успешно в селското стопанство, а компютърното зрение осигурява масиви данни за изкуственият интелект. Използването на интелигентни системи може да се свърже с прецизното и консервационно земеделие. Интелигентните системи в земеделието са практика, притежаваща ниски въглеродни емисии, която гарантира екологичната устойчивост на селскостопанските процеси. По дефиниция, изкуственият интелект е понятие, което обхваща набор от техники, които позволяват на машините да имитират човешкия интелект и човешката мисъл и създава програми, които реализират функции на човешкия разум. Една система има и ако отговаря на следните условия. Изгражда модел на околната среда, системата използва създание на модел на околната среда за изграждане на план на действие. Системата анализира алтернативни възможности, системата предефинира плана за действие. Системата използва предишен опит за подобряване на модела на околната среда. Какви са възможностите на ИИ в земеделието? Революционира и модернизира земеделски практики, помага при изпълнението на сложни и рутинни задачи, допълва съществуващи технологии без да ги измества напълно. Събира и обработва големи масиви от данни и създава модели за работа. Взема информирани решения, дава препоръки, предприема действия, базирани на алгоритми. Инструмент, който работи от дистанция с помощта на роботи и цифрово оборудване. Какви са възможностите на ИИ в земеделието? Обучава се и се усъвършенства във времето, редуцира грешки, помага за отглеждането на здрави растения, наблюдава здравето на почвата, оптимизира напояването, торенето и автоматизира прибирането на реколтата. Работата става по-ефективна, намалява участието на ръчния труд. И използва компютърно зрение. Компютърното зрение обработва изображения както ги прави човешкото зрение. Компютърното зрение позволява преобразуване на изображения, компютърното зрение интерпретира съществуваща информация и формулира решение. Целта на компютърното зрение е изграждане на модел за наблюдаваната околна среда. Защо да се използва ИИ в селското стопанство? Повишава се ефективността на времето, труда и използваните ресурси. Подобрява се устойчивостта на околната среда, интелигентно разпределение на ресурсите, осигурява се мониторинг в реално време за здраве и качество на продукцията. Практическо приложение на ИИ в селското стопанството. Мониторинг на културите и почвите, откриване на болести и неприятели по растенията, интелигентно пръскане и торение, прецизното земеделие, дистанционно проучване и заснемане, изготвяне на прогностични модели. С мониторинг може да се следи за ерозия, pH, хумус, органично вещество, микро и макроелементи, наблюдават се различни фенофази, идентифицират се проблемните области и се предприемат действия за опазване на културите. Откриване на болести и неприятели по растенията. С ИИ компютърно зрение автоматизира откриването на болести и вредители по растенията. Използват се методи за класифициране, откриване, сегментиране на изображения, с които се изграждат модели. Интелигентно третиране с пестициди и торове при прилагане на прецизно земеделие. Компютърното зрение и ИИ разпознават целевите групи вредители, определят зоните за третиране и работят прецизно. Целта е и за постигане на оптимално покритие на засегнати от болести и неприятели зони и намалява разходите. Дистанционни методи за анализ на въздушни изображения. Помагат при проучване, наблюдение на пасища и обработваеми земи чрез използване на сателити и дронове. Фермерите получават известия за проблемите в своите полета без да ги посещават постоянно. Въздушните изображения подобряват прецизността при работата с пестициди и торове и минимализират въздействието върху околната среда. Автоматично плевеление. Отстраняването на плевелите чрез роботи с компютърно зрение и е екологично без участието на ръчен труд и спестява усилия. Физическото премахване на плевелите спестява работата на фермера и намалява нуждата от хербициди, това прави земеделското производство по-екологично. Класифициране на готовата продукция. С ИИ може да се сортират плодовете и зеленчуците по размер, форма, цвят и обем. Прогностични модели. Как работят прогностичните модели на метеобот? Моделите изготвят прогноза за болести и неприятели, като отчитат условията, от които зависи тяхната поява и развитие. Моделите са заложени правила и алгоритми, получени в резултат на полеви опити и научни изследвания. Заложените алгоритми отчитат биотичните фактори, данните за модела се получават директно от метеостанцията и с тях се прави прогноза за момента, силата и вида на следващата зараза. Как се интегрират моделите на метеобот в практиката? Извършва се третиране само ако е необходимо. Избира се се резидентността на патогените, облегчава се работата в натоварени периоди, ползва се схема за интегрирана растителна защита. Как се интегрират моделите на метеобут в практиката? Подходящи за биологично производство, по-широко използване на контакти или генерични препарати за растителна защита, моделите за пшеницата и ечемик има информация за фенологично развитие на растенията. Моделите изготвят динамична прогноза за момента и степента на риска от зараза. Стопаните трябва да приложат модела на време. Цел на прогностични модели – третиране на растенията с препарати за растителна защита при необходимост, но с най-подходящия за случая препарат. Благодаря за вниманието.
Brancia Adriana Virgil is here. The topic biodiversity of the viola genus in Oltenia, and your mentor is Mariana Niculescu.
Good day everyone, my name is Brancia Adriana Virgil. I'm coming from the Faculty of Agriculture, Craiova, and with the help of my coordinating teacher Niculescu Mariana, I'm going to present to you the biodiversity of the viola genus in Oltenia. General characteristics. The species of the Violaceae family are native to Europe. Most of them are spontaneous species. We met them in forests and meadows, but they can also be cultivated in parks and gardens. The Violaceae species are not pretentious at all. They need a nutritious substrate and a position in the shade. However, a few hours of sun in the morning will do them good. The Violaceae species reproduces very quickly through seeds and stolons. So in a few years, you will wake up with a carpet of blue flowers with an intoxicating smell. Because the characteristic of these flowers is the fact that they grow in groups, maybe because together they can more easily attract the few bees that fly during this period and that ensure their pollination. If you want a species of Violaceae in the garden, the most simple way to obtain one is to go to a forest or a place where they grow and divide a pair of bushes. You don't have to worry when planting them because viola rhizomes regenerate easily and resist transplanting. Violaceae species has cordate leaves and most species have a very strong smell. There are also unscented species that are part of the viola species, among which are Viola canina, Viola riviniana, Viola richembachiana. Their color is not as intense as the scented species. The color can vary from blue to purple and even white. Viola species are represented in the European flora by 123 species, among which 24 species are found in the Romanian flora. Following research in the Oltenia area, 13 species of viola were identified. And I'm going to talk about some species of Viola odora. Viola alba. It is found in forests, among shrubs, in the hilly and mountainous regions, up to altitudes of about 700 meters. In the research areas, Viola alba was found in the Luncăvăț, Oltănești, and Bistrița Vâlcii basins. In Oltenia, near the town of Horezu, two forms were identified, Variegata and Subcolina. Viola alpina, alpine violets. The little mountains violets found in the subalpine and alpine zone, on rocks and stony meadows on calcareous substrate, widespread in the country in the Ialomița Valley, Lake Balea, and in other mountainous areas such as the Carpathians and the Alps of East. In the Oltenia, the species is found in the alpine floor of the Parâng Massif. Viola arvensis. This species grows in cultivated and rural areas, among shrubs and meadows throughout the Oltenia area. Viola biflora. The species is found in mountain areas, on wet rocks, the edge of streams, and on calcareous substrate. It is spread in the mountains of Lotrului, in the mountains of Mehedinților, on the Poama Mohorului, in Parâng, the Căpățânii Mountains, Vulcan. Viola canina. The species is found in spontaneous flora through forests and meadows. The species was identified throughout Oltenia, in Lunca Jiului, the basins Bistrița Vâlcii, Olteț, Luncăvăț, Tismana, Sohodol, Oltănești, Gilor. Viola declinata. It spread from the subalpine to the alpine level, being characteristic for pastures with nardo stricta, in thickets, sunny places, on rocks, debris between 900 to 2000 meters altitude, rarely higher. It is found in all Oltenia basins. Viola hirta, it is found at the edge of forests, in groves, meadows, fallow ground. It is spread in all the basins of Oltenia. Viola odorata, it is often found in groves, shrubs, clearings, on the edge of deciduous forests, in meadows, along watercourses, especially in the hilly and plain regions, being common throughout the countries such as the Craiova region, Bucovăț, Lunga Craiovei, Palilula in the Solomon Forest, Podari in the Lotrului Valley, Gura Motrului in the Argintești Forest, Piliaș region, but also in Piatra Olt in the Milkov Forest Stetina region. Viola reichenbachiana. It is often found in the mountain flora through the forest being spread in the basins Luncăvăț, Olănești, Otăsău, Cerna, Bistrița Vâlcii. Viola reviviana. They are very difficult to distinguish from Viola sylvestris, so these plants from the shadier resort are closer to Viola sylvestris species. These forms are usually interpreted as the hybrid Viola reviviana and sylvestris, Viola intermedia. It is found in forests, in wet places, clearings, and next to watercourses in the region of the hills and the mountain floor. As for distribution in Oltenia, the species is found in all hydrographic basins in Oltenia. Viola rupestris. It is found in clay places, on limestones, gravels, on the banks of rivers, in forests from the mountain floor to the alpine one, such as in the Craiova region, Vâlciorova on the Vodiței Valley, Târgu Severin region, Bistrețu from the Băilești region. Viola suavis. It is found in forests, thickets, shady places, in river meadows, from the plains to the mountain floor, such as in the Craiova region, Reșca, Amărăști, at the Prapor Forest, Caracal region. Viola tricolor. Annual or hibernating plants that are found in wet meadows, at the edge of forests, through mountain meadows, on coasts and cliffs from the plains to the subalpine floor. The whole plant is used in medicine as a diuretic and in skin diseases. The use of violacee plants extends far beyond their beautiful and exciting aesthetics. From their ornamental value to culinary delights, medicinal properties, and cultural significance, these plants offer a diverse range of benefits to humanity. They add color, fragrance, and flavor to our lives, while also serving vital ecological functions. The appreciation, conservation, and exploration of the versatile violacee family continue to enrich our world with their grace and contributions. The violacee species encompass a captivating array of plants with diverse characteristics, ecological roles, and cultural significance. As we appreciate the beauty and value of the violacee family, let us also recognize the importance of conserving and protecting these remarkable species for future generations to enjoy and learn from.
The scientific coordinator is Maria Kozic. Have a plan.
Hello everyone, my name is Vojislav Lazovic. I'm a PhD student at the Faculty of Agriculture in Belgrade, and I also work as a junior researcher at the Institute of Soil Science, also in Belgrade. I would like to say that I'm very honored to have the privilege to present to you the main results of our paper named Aggregate Composition and Stability of Soil Structure of Rankers from Mountain Maljen in Serbia, carried out by my mentor and coordinating teacher Marija Ćosić, Professors Boško Gajić and Ljubomir Životić, my colleagues from the Institute, Mira Milinković, Biljana Sikirić, and of course myself. First of all, let's say something about rankers. Rankers are a part of the automorphic soil order in the national classification system. They belong to the humus accumulative soil class, and they are formed on very steep slopes in hilly mountainous areas. The natural vegetation of these soils is mostly grasses and less often forests, and they are formed in all climatic conditions from semi-arid to extremely humid climates. They are characterized with the following soil horizon sequence, either AR, AC, or ACR. And about more than 400,000 hectares of rankers are distributed in Serbia according to Dugalić and Gajić. As far as soil structure goes, it refers to the natural organization of soil particles into different forms under the influence of pathogenic processes. Soil aggregation is a very complex process, and it is a result of many different factors, including various soil properties, environmental and plant factors, as well as human interventions. The stability of soil structure is one of the most important indicators of soil degradation, the stability of soil structure is often used as a measure of soil structure. And the goals of this study were to, as you can see, A, perform an analysis of soil structure of rankers from mountain mullion after dry and wet seeding the samples, and B, assess aggregate composition and the stability of structural aggregates through various soil aggregation indices. The study was carried out in the eastern part of Mullion Mountain, which is located in western Serbia. The mountain spreads about 25 kilometers wide in west-eastern direction, and its highest peak is called Kraljev Sto, with an altitude of 1,104 meters above sea level. The study area is characterized by a mountainous climate with a mean annual temperature of 10.4 degrees Celsius and a mean annual precipitation of 965.1 millimeters in the period from 1997 to 2016. The relief of the study area is also mountainous with moderately high and high slope gradients, and the vegetation is mostly grassy and very dense, except on very steep slopes where it's practically non-existent. The dominant land use on this area is pastures used for extensive grazing. The field research was conducted in May of 2022, and at that time 13 soil profiles were opened until the appearance of solid rock. Soils were of course described on the field, disturbed soil samples were taken from A horizons of every soil profile, so a total number of 13 soil profiles have been analyzed in the laboratory. And it's important to note that profiles were opened at unrepresentative places due to the exposure of bedrocks on the surface of the soil. So profiles haven't been opened at typical places, but rather at places where there was enough soil for such an endeavor. The main physical and chemical characteristics that were determined using the following methods. Particle size distribution was determined by combining sieving and pipette methods. Soil texture was classified using the USDA triangle. Soil organic matter, or SOM, was determined according to the procedure described by Dugalić and Gajić, and soil organic carbon concentration was calculated as percentage of humus, you can see it here, divided with 1.724. Also, what I would like to note is that the aggregate size distribution was determined using Savinov's method, which uses dry and wet sieving, and that method is most commonly used in Serbia. The following structural indices and coefficients were determined: dry and wet mean weight diameters, MWD, dry and wet geometric mean diameters, GMD, structural stability index, SI, and as well as coefficient of structure, KSTR. And here on the right side of the slide, you have classification of soil structure in accordance with SI values in percentage proposed by Pieri, as well as KSTR values classification according to Shane from 2001. Here in this table, we have the results of particle size distribution, soil texture, soil organic matter, and soil organic carbon content. And upon first glance, we can notice that the particle size distribution is dominated by the silt fraction, with the lowest value being 45% in profile 8. As far as soil texture goes, 12 out of 13 soil samples have a sandy, silty loam soil texture, while profile 8 has a loamy texture. All soil samples have a very high soil organic matter content with an average value of 14.19%. And in accordance with that, soil organic carbon content is also very high, and it varies from 559 in profile 6 to 1075 in profile 12. These soils were correlated with the leptosols reference soil group of the World Reference Base Classification. 12 of them were correlated with the leptosol reference soil group. Profile 10 was correlated with the leptic Fausen's reference soil group due to its thickness, which was higher than 25 centimeters or 29 centimeters to be exact. On to the next table, where the dry aggregate size distribution is presented. The soil samples have been sieved through a column of 11.25, 3, 2, 1.5 and 0.25 millimeter sieves. And we can see that the aggregates which are the most represented are a size of 5 to 3 millimeters, and they have an average content of about 19.7%, which indicates that these soils have a favorable aggregate composition, which is also illustrated by the fact that the content of agronomically most valuable aggregates, which are a size between 0.25 and 10, or in our case 11.2 millimeters, exceeds 70% in all soil samples, which means that these soils have a very good structure and aggregate composition. What did I want to say is that the aggregates which are larger than 10 millimeters are not conductive to water and crop emergence, while the aggregates which are smaller than 0.25 millimeters can clog pores and damage soil permeability, and that's why they are not in that agronomically most valuable fractions. In this table, we have the results of wet sieving and soil aggregate stability to water, and we can see that in every soil sample there's a high content of mega aggregates larger than 11.2 millimeters with an average value of 7.9%, which indicates that these samples are very water stable, or the aggregates are very water stable, which is also illustrated by the fact that the water stable aggregates larger than 1 millimeter are, how should I say, are present in every soil sample with about 67.9% on average. So these rankers have very water stable aggregates, which is very good, of course. On to the last table, in which various structural indices and rankers from Mount Malian are presented. These indices are crucial for understanding the structural state of soils, together with dry aggregate size distribution and water stability. And we can see that the mean weight diameters were, as well as geometric mean diameters, were calculated using the results of dry and wet sieving. And the ratio between wet and dry mean weight diameters has values which vary between 0.65 and 0.96, which indicates that there was a small change in aggregate size after wet sieving the soil samples. And it's also the same applies pretty much for the ratio between wet and dry geometric mean diameters. As far as structural stability index goes, its values are larger than 9% in every soil sample, with the lowest value being 9.14 in profile 5, which means that all of these soils have a stable to very stable soil structure with minimal to no risk of structural degradation. As far as KSTR values go, they range from 2.18 in profile 13 to 7.17 in profile 4, and that means that in accordance with the classification shown earlier by Shane, we conclude that all of these soils have a good structure. And finally, upon conducting quantitative analysis, we can conclude that examined rankers have very good aggregate composition, favorable aggregate composition, with very water stable aggregates, which are indicated through the fact or high content of agronomically valuable aggregates, as well as a favorable ratio between wet and dry mean weight diameters. Also, the values of structural stability index and coefficient of structure very good and they indicate good structure and low risk of structural degradation. But despite all of that, during conducting field research, we saw various processes of linear erosion, such as gullies across slope length and soil creep on slope shoulders, which indicate that the study area is degraded even though the soil structure is very favorable. So we can only conclude that the soil structure is not the only soil erosion stabilizing factor, and in order to better understand this phenomenon, further research needs to be done. And that is all. Thank you very much.
Good day, everybody. My name is Alexander Zečević. I'm coming from Agriculture Faculty of University in Belgrade. The topic of my presentation will be aerobiological characteristic of some Cabernet Sauvignon clones in the condition of the central Serbia. The first, something about the content of the presentation. When we discuss about some land and agriculture, we will definitely consider the climate condition, temperature and rainfalls. Then we will discuss about the object and the aim of the research and the method that we used. And of course the conclusion kind of after all. Something about climate condition, about the temperature. We can see table 1 and table 2. Table 1 discuss about average monthly and maximum and minimum temperature. We can see this is the period of 1981 to 2019. We can see the vegetation minimum and maximum 70.8 and 11.3 for that period, and the period for the content of the aim of the research 2021. We can see the vegetation is approximately pretty much the same, 70.58 and 4.11. Then we will discuss about rainfall. We can see about the same period, 1981 to 2019. We can see the annual is 668.9. By the period of 2021, we can see the slight difference. It's more about 100 more milliliters per square meter than the last period. When we talk about the location of the research, the location is in Central Serbia. You can see the blue spot in the middle of the map. It's Central Serbia. The village name is Krnjevo. If somebody wants to know where is the village, he can use the GPS coordinates. Something about the object. The object was a winery Radovanović, and the research was conducted in 2021. Established of the vineyard is 2007 years. The location is Šumadija region, Krnjevo vineyard row spacing is 2.4 meters and 0.9 between vines in the row. The height is 90 centimeters, so that we use the Condor royal cordon. Something about materials. Materials, of course, the Cabernet Sauvignon. When we talk about the Cabernet Sauvignon, we will discuss about the synonyms. The synonyms are Boudir, Vigure Sauvignon, Veroni, Cabernet Petit. Something about the materials. We can discuss about the origin. Origin is from France, region Bordeaux. The ripening is very late, third epoch, and something about the yield, 6 to 10 tons by hectare. The aim of the research was to determine the difference between the clones. We have the French clones and the Italian clones. The French clones, we have 3 of them, clone 169, 191, and 412, and 1 Italian clone, E153. When we speak about the methods, we will use the phenological observation, determination of the mechanical compost, and the determination of qualitative parameters of the grape juice. When we discuss about the third method, we will discuss about the sugar, total acid, and pH. When we talk about the phenological states, they are pretty much the same dates for the all 4 clones. We can see the breeding of the grapes starts in the 24th March, barbarous 13 April, flowering 29 May, rising is 1st 1st August and the harvest is 1st October. When we discuss about the termination of mechanical compost, all the research was conducted in our faculty in the University Laboratory of Agriculture in Belgrade. Something about mechanical compost of the grape and the berries. We can see the graph, we can see the four of the clans. We used to conduct about the average bunch weight, average bunch height, average number of berries in the bunch, the average weight of berries. We can see the French clone 169 is leading by all parameters, followed by the clone 412, and the last, but no more important, two other clones is pretty much the same. We can see two more diagrams. We can see they're pretty much the same, but we can see the percent of the skins in the cluster. It's much more bigger in the Italian clone than the French clone. About the French clones, we can see that the clone 169 also in the percent of the skins in the cluster, it's much more bigger than the clone 191. When we discuss about the quality parameters of the grape juice most, we can see that the clone, Italian clone 153 has a much more sugar content than the rest of them, and the content of the total acid is 7.5 for the clone 191. About the pH, they are pretty much the same. And finally, about the conclusion, we can see, based on the research obtained, the result has been found that there is no difference in duration about the phenological states of the clones. The high sugar content was found in the Italian clone, the lower one from the French clone, and based on data and the result of the obtained, we can recommend it for the, we can conduct it that the test clones are suitable for growing the wine in central Serbia, that based on the parameters show they can be recommended for the producing high quality red wine. Thank you for your attention.
Short break from the serious presentation in a conference because it's small information about options to how it's possible to found options to make your studies and your work in with the possibility to take money from the European funds for that. Okay, so we have no, I'm understanding, but yes. So my opinion is that we have three general options to found European funds for our work. One more and more stronger is a LIFE program. Other one is Horizon program, and third is non-European funds. So that's what it's important to know that external funds is a good option to make the impossible things. What is possible to take from EU LIFE program funding? So they have these rules for money. One is nature and biodiversity, and I think that circular economy and clean energy is other options for funding. So this is the nature and biodiversity sub-program from the LIFE EU program. It's possible to see what is the focus of this program to stop the biodiversity losses and to manage the Natura 2000 network in Europe. This is very general things for the EU. Circular economy is to support green and energy efficiency things for all the EU stakeholders, and clean energy is third part of the options to fund the money from EU funds. Next options for funding is Horizon Europe. This program is changing several times. Maybe some of yours remember that first his name is Horizon 2020. Now the new name of this fund is Horizon Europe. So this fund is support generally partnerships and researchers for some new areas of knowledge. So most important for this program is to stop the climate change or to reduce the climate change effects, and it's possible to support some other things what you see, and that's maybe shorter options to fund the money for your activities. These programs, they have very good sites, internet sites, and it's very easy to found them in internet, and there is many information how it's possible to put the projects there and what is the options to make the partners. They are eligible and for Serbian colleagues, but only with collaboration with some of EU partners.